This presentation on winch-assisted harvesting showcases a significant technology innovation in New Zealand harvesting operations, coming out of the first primary growth partnership in steepland harvesting, managed by Future Forest Research, or FFR, the predecessor of Forest Growers Research, and co-funded by MPI and the forest industry, and supported by research at the University of Canterbury School of Forestry. The safety and productivity benefits of mechanical tree felling on easy country were well known, but the development of winch-assist enabled these benefits to be gained in steep slope harvesting operations. This winch-assist technology is now well established in New Zealand, but how did it come about? Since 2006, some new machines and systems were being developed by New Zealand contractors to mechanise felling and pre-bunching on slopes, with the aim of eliminating manual chainsaw felling and cable operations. In March 2009, FFR researchers visited Ross Wood's operation in Nelson with a view to studying his steep terrain bunching operation. This was initially an old Komatsu roller crusher tractor with a pre-tensioned winch drum brake. This system, designated A in the illustration on the left, is an active system, as the rope is moving up and down the slope as it is wound in or out to assist the feller buncher. At about the same time, the second machine that had been developed back in 2009 was being tested by Nigel Kelly of Kelly Logging Ltd in Nelson. This was a Hitachi excavator with a Satco boom and felling head with a built-in winch to aid traction. This was a single machine system, designated B in the illustration on the left. As it is a passive system, the winch rope is static as the machine moves up and down the slope, winding the cable in or out. This means less rope wear as it is not moving across the ground, and as the winch rope is tied off on stumps at the top of the hill, it does not require access to the back line or the top of the slope. So, at the risk of getting a bit technical, let's have a look at how a winch cable can be used to assist the traction capability of a ground-based machine on a steep slope. As shown on the figure on the left, the basic physics for retaining traction on a slope is that the gravity force pulling the machine downslope, Wg in red, should not exceed the traction force, T in blue, that the machine is able to develop on the ground surface. Otherwise, the machine will start to slide down slope. Put simply, the greater the traction force the tracks can generate in the soil, the steeper a machine can operate without slipping. The benefit of winch assist is that the tension provided by the cable will add to the traction force of the tracks and thereby greatly increase the operating range of the machine without it reaching its traction limit. Traction force is a function of the soil's coefficient of traction, which is sometimes called tractive efficiency, for a given machine type, either tracked or wheeled, and this is illustrated in the chart on the right. The slope limit is indicated where the Wg purple line intersects the traction line for a given coefficient of traction. In this example, if the soil had a coefficient of traction of 0.4, the blue line, a 37-ton machine would start to slip on a 22-degree slope without traction assistance. By adding a winch assist with 10 ton of tension provided by the cable, C, represented by the black arrows, the traction force is augmented by the cable force, which extends the operating limit of this machine to about 37 degrees, a major improvement in operating range on steep slopes. But winch-assisted harvesting is not new, with this machinery commercially available in forest operations in Europe since the 1990s. A number of different companies were offering cable assist products, initially on forwarders and later on harvesters, to expand ground-based harvesting onto steeper terrain. The separate winch units were mounted to the rear of the machine, as shown bottom right of this illustration, and more recently for skidders, top right. In Europe, independent self-powered winch units were also being developed, as shown in the bottom left. However, New Zealand conditions include very steep slopes and unstable soils, in combination with large tree size, which has required larger felling machines with larger winches and bigger diameter wire ropes than were commercially available in Europe. So in New Zealand, the tracked excavator winch-assist systems were developed, as illustrated in the top left. Let's have a closer look at the range of winch-assist machinery. In Europe, the most common approach was to mount the winch onto the chassis of the primary machine. A number of manufacturers preferred the bolt-on option to provide the opportunity to remove the unit when not required. This EcoForce T-winch is one of the first independent self-powered remote winch units, which was developed in about 2012. In New Zealand, the first commercial winch-assisted harvester was the ClimbMAX steep slope harvester developed by Trinder Engineering of Nelson, with funding assistance from the Steepland Harvesting PGP. It had an integrated winch mounted into the track frame of a Hitachi excavator with a Trinder boom and felling head. Shortly afterwards, Electrical and Machinery Services, or EMS, in Rotorua produced a dual winch system on an excavator base, which they called the traction line. This has been a very successful development. Shortly afterwards, Rosewarne May Ltd in Whangarei produced the Remote Operated Bulldozer, or ROB, Winch-assist, which is a dual winch mounted on a hydrostatic drive John Deere tractor. And DC Equipment Ltd of Richmond Nelson produced the Falcon Winch-assist, a single drum winch on an excavator base. And in the US, Summit Attachments and Machinery Ltd in Washington State produced a single drum winch on an excavator that had a boom extension. And in British Columbia, Canada, Timar Industries produced the LogChamp Remote Winch-assist, an independent self-powered winch unit similar to the EcoForce T-winch. So looking at some data from the FGR benchmarking database run by Dr. Reen Visser at the School of Forestry, from 2013, the database started to record operations on steep slopes using winch-assist. This early analysis in 2014 of only 13 mechanised felling operations compared to manual felling showed operations on steeper slopes with higher productivity and lower costs than manual felling. A survey in 2016 found that over 90 winch-assist machines had been manufactured in New Zealand. There are now 4 main New Zealand companies manufacturing winch-assist machinery: ClimbMAX Equipment Ltd, EMS, DC Equipment, and Rosewarne May. Together, they have reportedly manufactured more than 270 winch-assist machines since the first commercial machine appeared in 2012. The Benchmarking Harvesting Cost and Productivity project has been running now for about 12 years, and the data tells us that around 65% of cable harvesting operations in New Zealand now have access to winch-assist machines. That's about 200 machines across the whole of the New Zealand logging industry. With regard to safety, consideration of the actual tensions in the winch rope becomes critical. If the machine is not stable on the terrain without the cable. From 2014, work at University of Canterbury School of Forestry by Hunter Harrell looked at winch rope tensions. From these studies, it was found that average tensions during felling and shoveling were usually below the safe working load of the winch rope. But tensions during machine movement often exceeded safe working load. In this example, was 14.2 tonnes. For very short periods, which are the blue spikes seen on the chart, and during the moving phase only. From 2016, the School of Forestry has been running workshops on winch-assisted harvesting, using information from FGR harvesting projects and the benchmarking database. to undertake operational planning of productivity and cost, supporting contractors and operators in the safe use of winch-assist, and to determine areas for further research and development. Some of the things that the workshops have been looking at. Operating techniques. In New Zealand, most operators use trees or stumps to change the rope angle to facilitate better machine utilisation. When the feller buncher gets to the top of the ridge, they go around the next stump and back down the hill to avoid shifting the winch machine on every pass. Some manufacturers' guidelines specifically allow for the use of these hold stumps. However, there have been issues with the winch rope pulling over trees or cutting through the stump, causing hold stump failure. Another issue on the subject of safe use of winch-assist machinery, the workshops looked at areas such as the connectors between the winch rope and the felling machine. Which ones are best and how to inspect and maintain them. So coming up to date, there are a number of recent or planned studies to be undertaken by University of Canterbury School of Forestry of different applications with skidders, forwarders and harvesters. They include a skidder extraction study using a Falcon winch assist at Spears Logging Limited's operation in Gisborne. The winch assist gave the skidder the ability to extract away from the riparian zone, hauling loaded uphill. The skidder was operating on slopes up to 33 degrees with an average of 25 degrees adverse. Utilisation of the winch assist was increased when used by the skidder, up to 80% utilisation, compared to just the falling machine, which was 50% utilisation. In another study of a cut-to-length harvester forwarder operation near Napier with Rainier Matariki Forests in April this year, a John Deere 1910 forwarder was operated supported by a T-winch Model 10.2 winch assist. In the same operation, the harvester was using a traction line winch assist for cut-to-length processing at the stump. Delimbing on the slopes, which was first mooted back in 2013 in an earlier FFR study, is now a reality with the use of winch assist. Stumps are used to hold the logs in place on the slope, and designated slash tracks are set up for the forwarder using processor slash to reduce ground disturbance. So in closing, there have been a number, or numerous studies of winch-assisted harvesting operations published over the last 10 years. Some of the FFR and FGR studies are listed here. Winch-assist harvesting systems have seen rapid adoption and implementation in Europe, New Zealand, and North America during the last 10 years, and continue to do so in other parts of the world. This technology is considered to be one of the major innovations in steep terrain harvesting in the 21st century. There will continue to be more research undertaken looking at machine stability, safe operation, environmental impacts, and system productivity and costs, not only comparisons between winch assist and conventional systems, but also between different winch assist systems themselves. We expect the substantial body of literature will continue to grow. The FGR project has been a collaboration between Forest Growers Research, supported by the Forest Growers Commodity Levy, and MPI through the PGP, and forestry company stakeholders, and the University of Canterbury, notably Dr. Reen Visser at the School of Forestry, and of course New Zealand manufacturing partners. The focus on mechanisation and modernisation of steep terrain harvesting systems across the industry over the last decade has shown significant improvements in both productivity and safety. A major step change has been the development of winch-assist technology. Winch-assist has proven to be a robust, safe and high-performance forest harvesting technology that has significantly increased the operating range of ground-based mechanised harvesting on steep slopes. Thank you.